Okay, so in the previous video, we discussed there is a proper order in how we write down the base pairs of a DNA chain. Because we get lazy very often, we don't want to draw these phosphates and these sugars and these bases. We just really want to simplify things sometimes because we understand that the ribose is there. We understand that these bases are A, T, Gs, and Cs, and we know that there's nitrogens involved, and we know that there's functional groups involved, and then we know that they're all hooking up from 5' to 3' ends. So that's okay. I don't want to draw that every time because my hand's going to get very tired. So very often we shortcut the entire structure and we just look at order of bases because let's face it, that's what this thing is all about. My base pairs are ordered in a different way than your base pairs. And that's why we are all different from one person to the next because these base pairs are slightly out of order depending if you go from person to person to person. So that's what we need to focus on. How can I represent that? Well, we always, like we said previously, go from 5' to the 3' end. That's very important. So when I write down an order of a base pair, or the order of the bases. Again, the 5' is on the 5th carbon. So that is where I start on the chain, and then I go toward the end that is ending up with the 3' carbon. So when I write down something like A, T, G, and C, well, I know that this is DNA because I see the T that's there. And if it wasn't DNA, the T would not be used. A U would be used, and that would be RNA. So because of that, I don't really have to write anything in front. It's kind of redundant. But some people do put a D out here in front to let me know that this is a DNA strand. Just in case the T didn't give you that insight, well, that small little D in the front can do that as well. So that D does represent DNA, and that DNA is going to have thymine and not uracil in it. Now, why do we even put the D out in front then? Well, there's going to be some times where you will get a fragment and T will not be in that fragment, and you will not find a U in that fragment. This could have been AAAGC. And A's are in both DNA and RNA, G's are in DNA and RNA, C is in DNA and RNA, and we wouldn't know which one we're referring to if that was the case. So sometimes I can put a D there in front to let you know in cases like that that we are referring to the DNA version and not the RNA version if that matters. So again, this was redundant because the T is there. I automatically know it's DNA now that we're talking about, not RNA. If that was a U, I would automatically know that's RNA that we're talking about and not DNA. So sometimes they do put a D there in front. We also said that here at the end, sometimes they will end this with a P, and the P basically means that is the ending pair. A lot of times they reserve that to the true end of the actual chain itself. If that's the case, then after that C base, there's nothing else that follows. If this P was not there, however, sometimes we interpret that as being just a small sliver of the DNA chain. So this is just a small portion that we're pulling out, that we're focused on, and there's other bases that follow that C. And that's why I do not put the P there on the end. So a lot of times people will look at this and just interpret that P as the true end of the DNA chain or RNA chain. If the P is not there, we kind of assume that this is a fragment or portion of the 1 billion bases that I might be looking at a time. So just a little rule of thumb, that's all that we're doing. We're just getting our P's and Q's situated. That's it. Okay, so this is what we call 5 prime to 3 prime. So this is assuming that the A is on the 5 prime and the C is on the 3 prime. So in this DNA chain, remember this was a sugar, phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate. I'm just going to kind of draw that line to represent the sugar phosphate backbone. That's what that means. And then here I get my first base of an A, and then I get another A, and then I get another A, then I get a T, and somebody give me a G, and then I get a C. And then I'm just going to put dot, 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 because that could continue on. And I'm going to put dot, dot, dot here, because that could continue on in that direction as well. But this is my 5 prime to 3 prime end. That is what we want you to take away from this video portion of the lecture. Okay, so this is one strand of DNA, and then we know it's DNA because there's a T there. And this one strand of DNA, like we've said before, has a complementary strand. And that complementary strand will be drawn up here. There you go. And then we said that these bases have particular base pairs, and those base pairs come to us in a certain order. So here the A pairs up with the T, an A pairs up with the T, an A pairs up with the T, the T pairs up with the A, G pairs up with a C, and the C pairs up with the G. So this is my complementary strand. So I'm just going to label this as my complementary strand. So I put comp there to let you know that's the matching strand, the sister strand that comes along with it. And then the order of that strand runs backward. So another thing that you got to keep in mind is that this is my original strand that I started with. So this is my 5 prime end. This strand actually runs backward. So my 5 prime and 3 prime go in an opposite direction. That's the way that these strands actually match up and stay together. So if you write your original strand down in the 5 prime to 3 prime end, and you put 5 prime to the left and 3 prime on the right, then the complementary strand runs in the opposite direction. So they are parallel, if you want to view them that way. So this is my 5 prime end, and that means my complementary strand, this would be the 3 prime end. Here's my 3 prime end, and on the complementary strand, that is my 5 prime end. So that's the way that we represent the complementary strand. It does run backward than convention. Convention is 5 prime to the left, 3 prime to the right, and in the complementary strand, it does go backward. So that is one of the ways that we talk about writing down a DNA information or RNA information, writing down the order of the base pairs, and how we can. So that's the story, and I'm sticking to it. And in the next video, we will take a look at the 3D structure, finally, of DNA. So enough of this 2D stuff on a sheet of paper. Let's really take a visual representation of what this thing will begin to look like.